do the permutation on the calculator, on the yellow calculator. So if you're watching the video, let's say 4 factorial. Hang on a second. So let me just over here, and I know 4 factorial is not a big deal, but if you want to do it in the calculator, you press 4, and then you're going to press probability. There is PRB, and then you're going to select the number 3, the third choice. So 4 factorial, there's a PRB button. You'll see it's right on the third column, 3 down, and then you press 3. Press enter, of course, and you get 24. Okay, so if you're listening, if you're watching, that's it. So the first one is, well, 2 factorial is just 2. 3 factorial is 3 times 2, which is 6. 4 factorial is 4 times 3 times 2 times 1, 12, 24. And we got over here 12 times 24. And this is 288. All right, so this one definitely comes in handy, the button I was talking about. 12 factorial is 47. Did I do this correctly? 12. Probability 3. Enter. Yeah. 479001600. 479,000,1,600. 4 times 3. So this one is 4 first, and then so we have to figure out what 3 factorial is. 4. 3 factorial is 3 times 2 times 1, which is 6, so this is 24. 4 factorial is 4 times 3 times 2 times 1, which is 12. 24 minus 3 factorial, which is 6, gives you 18. Over here, 8 factorial over 5 factorial, so we can write 8 times 7 times 6, and you know what? We can write that, so that way this 5 factorial and this 5 factorial goes away. 8 times 7 times 6, oops. 8 times 7 times 6, and this is going to give us 336. And 8 factorial over divided by 1 is just 8 factorial. You don't even have to do it. But just in case you did, 8 prob 3 equals 40,320. Okay, so again, if you didn't watch the video, tomorrow I'll show you how to use the yellow calculator. Okay. All right, so again, besides that, every other question we did this one we did a week ago, but this is sort of a repeat. But with new notation, right? So how many 4-letter code words can be formed using 26-letter alphabet? If repetition is allowed, it's 26 times 26 times 26 times 26, and I'm going to leave it as 26 to the 4th power. If it's not, it's 26 times 25 times 24 times 23, and actually, you guys can multiply that out and figure out what the number is. So now is a, what do you call, license plate, 3 letters, 3 digits. So again, look at the, so these are letters, so letters here, and these are for digits, all right, license plates. If no repetitions of letters are permitted, so 26, letters cannot be repeated, so it's going to be 26 times 25 times 24, and then I'm assuming, because it doesn't say otherwise, the numbers can be repeated. That would be our answer. The bottom one, if no letters and no digits are repeated, how many license plates are possible? So you can actually write it like this, 26P3 times 10 10P3 as well, right? So this, again, is just a fancy way of writing 26 times 25 times 24 times 10 times 9 times 8, because the numbers cannot be repeated. And like I said, you guys can multiply that. Okay. How many different 3 number combinations can be made? Okay, so we're taking 40 numbers, arranging 3 different ways. So it'd be 40 times 39 times 38, right? And you get whatever you get. Wait a second. How many different combinations can be made? Ooh, 3 different number combinations can be made. It didn't say if it was, what do you call, if we could repeat it or not. Okay, because the letter B says how many different combinations are there if the numbers must be all different. So for A, I guess this would be letter B, and then for A, if they can be repeated, it would be 40 times 40 times 40 using the digits 1, 3, 5, 7, and 9 with no repetitions of the digits. So you cannot repeat. How many one-digit numbers can be made? Well, if you can't repeat and it's only one digit, how many choices do we have for this one? We have 5. B, it's two-digit number, so how many choices we have for the first spot? 5. How many choices we have for the second spot? 4. That would be 20, or if you did write it, you could have written it like this. 3 digits, 5p3, so it would be 5 times 4 times 3, which is 60. 4 digits, so it would be 5 numbers, arranged 4 different. Taken 4 at a time would be 5 times 4 times 3 times 2, okay, which is 20. 60 times 2, 120. There are 5 members of the math club, and how many ways can the positions of officers, a president and a treasurer, can be chosen? Well, you can only have one president, one treasurer, so obviously you can't be the same person can't occupy both positions. So 5 members taken 2 ways would be 5 times 4. So we can have 20 different arrangements here. The baseball team has 9 players. Find the number of ways the manager can arrange the batting order. So you have 9 players arranged 9 different ways, right? So how many different ways can we do this? Right? So this would definitely be 9 factorial. 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. So 9 prob 3. And that is going to give, you can have 362,880 different lineups. It's 9 players. Wow. Find a number of ways of choosing 3 initials from the alphabet if none of the letters can be repeated. Okay, so 26 letters. We're going to put them in these 3 spots, and then we can't repeat them. So it'll be 3 different ways. So it'll be 26 times 25 times 24, and you guys can multiply that out. All right. So again, like I said, most of this stuff we did this, so it's pretty easy. Number 1 here, 6p3. Okay, would be 6p3 would be 6 times 5 times 4. It's asking us to evaluate, so 6 times 5 is 30. 30 times 4 is 120, so A is 120. B would be 10 times 9, which would be 90. C would be 25 times 24, which is 600. D would be 4 times 3 times 2, which is 24. E would be 20 times 19, which is 380. F would be 11 times 10 times 9 times 8. Times 9 times 8, and that's going to give you 7,920. G is going to be 22 times 21 times 20. Times 21 times 20. 9,240. 10 is going to be 10 times 9, H is going to be 10 times 9 times 8 times 7. Ouch. So that's going to be 90 times 56, 5,040. H, was that H? I, it's going to be 7 times 6 times 5 times 4 times 3 times 2, 1, 2, 3, yeah, times 2. So it's going to be 5,040 as well. I, J is 101 times 100 times 99. 1 times 100 times 99, which is going to be 990,900. K, it's 8 times 7 times 6 times 5 times 4, right? We're going to go 5 down. 5 down. 8 times 7 times 6 times 5 times 4 equals 6,720. L is going to be 6 factorial. 6 prop 3, 720. Okay, so that's pretty easy. How many 3-digit letters can be formed from the letters if each letter is using only once in a word? Okay, so lion. How many 3-letter words can we make using the word lion? The letters from the word lion. So it's 4 letters. 3. We can go 4, 3, 2. So that equals 24 different words, 3-letter words. Using the letter tiger, that's 5 letters. Arrange 3 different. Taking 3 at a time. Be 5 times 4 times 3, which is 20 times 3 is 60. Monkey has 6 words, 6 letters, sorry, 6 taken 3 at a time, so 6 times 5 times 4, which is 120. Leopard has 1, 2, 7 letters, so 7 letters taken 3 at a time, so it'd be 7 times 6 times 5. What is this? 30 times 7, 210. And man, 3 letters taken 3 at a time. Be 3 times 2 times 1, and that's going to be 6 possible words. Not words, well, even if they don't make sense, even if they don't create a word in the dictionary, but we can arrange them in 6 different ways. 30 students in the class. Every day the teacher calls on a different student to write homework problems on the board, with each problem done by only one student. And how many ways can the teacher call students on the board if the homework consists of only one problem? So there's only one problem. 30 students. How many different choices can the teacher call when there's only one problem? Well, 30 different students can come in. When there are 2 problems, there's 30 students. We gotta take 2. Take 2 of them, and we're gonna go 30 times 29. So if there's 30 students in the class and 2 problems on the board, we can have 30 times 29, 870 pairs, different pairs come up to the board. But if there's 3 problems, 30, P3, 30 times 29 times 28. So if there's 3 problems on the board, 30 times 28 times 28, 30 times 29 times 28 is 2. Wow, we can have 24,360 trios come up to the board, different trios. Last 3. How many possible winning orders are there for a horse race where 3 horses finish in winning positions are there when there's 7 horses? So when there's 7 horses, right? How many different first place, second place, third place horses can we have? Different horses can we have? So it'd be 7 times 6 times 5. So what's that? 30 times 7, 210 different ways for first, second, and third. When there are 9 horses, be 9 times 8 times 7, 9 times 8 times 7, and that's going to give us 504. And there are 11 horses. 11 times 10 times 9, 990. And finally, when there are n horses, okay, so it's going to be n times n minus 1, right? There's always 1 less, times n minus 2. Right? Well, that's it.